Our goal for this lesson is to solve inequalities that involve polynomials. So if we look at example 1, we want to know when is x squared minus x minus 6 less than 0. So a good place to begin once we have 0 on one side is to start by factoring. So the logic behind that goes, if we can factor, then we can figure out where the zeros are. We can plug in values that we can determine whether the function is positive or negative on each interval. And that's exactly what this question is asking. When is this function negative in this case? So we start by factoring. Then that allows us to find the zeros. Then we mark those zeros on the number line here. And we can see that when we pick numbers that are bigger than 3 for x, this first factor will be positive, as will the second. And when we take a positive times a positive, we get a positive. But we wanted to know when was x squared minus x minus 6 less than 0. So if it's positive, it is not less than 0. That product is not less than 0. So that makes the inequality false. So 3 to positive infinity would make the inequality false. Now if we pick a number like, say, 0, which is on the interval from negative 2 to 3, between the two zeros that we found here by factoring, we would get 0 minus 3, which is a negative number, 0 plus 2, which is a positive, and a negative times a positive is a negative. On this interval, we're getting negative values out, because once it's true for one of the values in that interval, it's true for all of the values on that interval, because there are no other zeros other than the two that we've identified here. Now, the original inequality wanted to know when was this less than 0, and when we're negative, we are less than 0, so we're making the original inequality true on this interval that we have here. And then finally, our final interval goes from negative infinity up to negative 2. So I can pick a number like, say, negative 10. If we do that, the first factor would be negative 13. More importantly, just a negative number. The second one will be negative 8. Again, a negative number. And a negative times a negative would give us a positive value for the product of those two things. So x squared minus x minus 6 is positive on the interval from negative infinity up to negative 2. And that makes our inequality that we started with here false, because the question was, when is this product negative? So, based on what we've done here, we can see that from negative 2 to 3, on this interval right here, the function would be negative, the product would be negative, and that would make our inequality true. So what we want is the interval where this is true, and the interval where this is true is as we go from negative 2 up to, but not including, positive 3. So we can say that x squared minus x minus 6 is less than 0 on this interval that we have right here. To complete this problem. Step 1, we found the zeros of the function. We found the zeros in this case to be 3 and negative 2. Step 2, plotted them on a number line. Step 3, we tested values in each of the regions created by the zeros, see whether it was positive or negative, and made the statement true or false. It makes the one of those values on each interval true, all of them will be true. Likewise, if one of them is false, all of them are false on each interval between the zeros. And then the final answer should be the intervals where the inequality is true, using proper notation. And again, we use parentheses when it is either a strictly less than or a greater than situation, and we use brackets when it's less than or equal to or greater than or equal to. We could have done the same process on a graph. So if we look at where are the y values on this graph is the graph of the original polynomial that we had, x squared minus x minus 6. If we look at where that's negative, where that's less than 0, the y values are smaller than 0 on the interval that I'm tracing out with my highlighter right there. The intervals will be, the y values will be larger than 0 when we're bigger than positive 3 and when we're smaller than negative 2. So from the graph, we can see that the y values are negative on the interval from -2 to +3, not including either -2 or +3. So we come to the same conclusion here as we did over here. That is example 1. And these are the steps that we went through to